back to my online teaching platform. Still on how to determine the derivative of a function from the first principles. Now we have a question here which says that show that the derivative of a constant is 0. So we have to show that the derivative of any given constant is equal to 0. So let us state our constant. So we can use C to represent the constant. So let C be equal to the constant that we want to differentiate to get a result of 0. All right. Now, anytime you have a constant, we can rewrite it as a function, and that function is called a constant function. So we can say that our function y will be equal to C, which implies that the function f of x is equal to C. And you should know that when you have any constant, and you have a function which is in terms of x, it means the constant is multiplying x exponent 0. So we can rewrite this one as f of x is equal to C multiplying x exponent what? 0, where C is our constant, because x exponent 0 will give us 1. So that value times C will give us C. All right, so this is what we'll be using to show that the derivative of any given constant is equal to 0. So let us put down the formula for finding the derivative from the first principle. So dy dx is equal to f of x plus h minus f of x, all divided by h. But I've omitted my limit, so let me bring it back. So it's equal to the limit as h approaches 0. All right, let us continue. So you know our original function, which is f of x, to be the same as c x exponent 0, and our f of x plus h will be equal to c multiplying, wherever you see x, you replace it with x plus h. So x plus h in bracket, all having an exponent of 0. So we can now plug in the various components into the formula. So we have our dy dx equal to the limit as h approaches 0. Then we have c multiplying x plus h, or in bracket having a power of 0, minus the original function, which is c x power 0, all divided by h. All right. So we'll be getting the limit as h approaches 0. Then we have x plus h having a power of 0, and that will give us 1. So we are going to get c times 1 multiplying another one, which is c times 1. So we have 1 here, all divided by h. All right. So we are going to get the limit, and c times 1 give us c minus c times 1, which is also equal to c, all divided by h as h approaches 0. So you can see that c minus c will give us 0. So the numerator becomes 0 divided by h as h approaches 0. So you'll be getting the limit of 0 as h approaches 0, because when you divide 0 by h, you divide 0 by any number except 0, you are going to get 0. So this will give us a constant function. So the limit of any constant function is the same as the function. So this becomes 0. So we conclude that therefore the derivative of any constant, so we can put c over here. So the derivative of c with respect to x, let me write it well. where we have already indicated that c is a constant must be equal to 0. So this implies when you have maybe a function which is equal to 2, and you have to find dy dx, this simply means that our dy dx will be equal to 0. Even if the function is negative 100, you still get your dy dx to be equal to 0. So this is the derivative of any constant term. Thank you for watching, and do not forget to subscribe to my YouTube channel, which is Math with Ebefa. Bye.